Hi guys, okay, welcome to yet another video on speed time graphs. Okay, check this out. Okay, basically what I have here, I've got two graphs, a displacement time and a velocity time graph. Okay, just a bit of caveat here before we start. The displacement time and the velocity time is similar to the distance and speed time graphs. Okay, reason being my ambulance here is basically just moving in a straight line. It's not going to do any bending or going backwards or anything like that. Okay, so with that, let's just head straight in. Okay, first scenario. Okay, you can see my van is not moving. It's basically at the 30-meter mark. That's why as time goes by, it's at 30 meters. What about the speed time graph? Speed time graph is, oh, let me just go back. My speed time graph is actually at 0 meters per second, which makes sense because my van is not moving, right? Okay, so let's move on to the next example. You can see my displacement time graph has got some constant. What does it mean? Constant gradient from our previous video on distance time. It means it has a constant speed. So does that show over here in my speed time graph? Yes. You see, my speed is always at 5 meters per second, right? So let's finish it up and go to the next example. Next example is a little bit more interesting here. You can see my gradient of my distance time graph is actually increasing here, right? So as it increases, that means my speed is also increasing. Oh, can you actually see? Oh, my speed here is increasing as well. Okay, so something interesting to take note of. Okay, as my speed is increasing, what is this? How do I actually find what does the gradient actually give me? So gradient, as what you know in maths, is actually rise over run. So since this is speed, on the vertical axis is final velocity minus initial velocity. So v minus u divided by the run, which is over here, t, the time taken. So what does rise over run give me? So v over u, v minus u divided by t. Sounds familiar? Yes, you're right. It gives me acceleration. Okay, so what do we have here? Our first relationship in a velocity or speed time graph is 3, 2, 1, boom. Okay, it's that gradient is equals to acceleration. Okay, so just like our previous one on distance time, a gradient, where the gradient shows the speed, in a speed time graph, the gradient actually shows us the acceleration. Okay, so let's get this out of the way. Just continue and move on. Next example. Whoa, you can see it's actually slowing down. My truck, my ambulance, slowing down all the way to a stop. Oh, sorry about that. All the way to a stop. Okay, let me just stop it here. Okay, you can see it actually stopped here. So what does this show? Okay, as it's stopped all the way here, okay, it means you can see initially it's traveling more distance for every 2 seconds and less distance. So what does this mean? Basically, this is a negative gradient, it means it is slowing down. That means the opposite of acceleration would be deceleration. Okay, so just more interesting examples. Okay, you can see here what's happening here. The truck, oh, from a low speed to a higher speed. Oh, here you can see in the distance time graph, this is a lower speed, higher speed because of the gradient. So that's why initially it's a lower speed to a higher speed as well. Same thing for speed time graph. Okay, and then this last example, not moving, has come to a stop. So and one more, you can see. Oh no, this one we have gone to the stop. Sorry, just sorry. Okay, so it has come to a stop. Okay, and that's about all. for you for this slide. Okay, so just a recap for speed time graphs. So speed time graph show two things, shows the speed at a particular time, as well as the next thing, which is more important, is the gradient gives me the acceleration. Okay, so first scenario, just to recap, you can see here that the line is horizontal. So in the speed time graph, if it's a horizontal line flat at the bottom, it means the speed is zero. Speed remains at zero, it means it has zero acceleration. Doesn't change the speed, right? So what about if it's still a flat line but slightly above, for example, at 10 meters per second, that means it's still zero acceleration, but it's moving at a speed of 10 meters per second. Okay, third one. Okay, third one, if I have a positive gradient, constant gradient for in a speed time graph. Oh, okay, you know here, gradient means acceleration. So just using this relationship here, if I have a positive gradient, constant gradient, I mean constant gradient will show me constant acceleration. Okay, the opposite is also true. If I have something has negative gradient, okay, constant grade negative gradient will mean deceleration is constant. Okay, constant deceleration. Okay, so the opposite of constant will be non-uniform. So the increase in speed is increasing if I have a positive increasing gradient. So what does this mean? You can see that my gradient, if I were just to pull out my pen, my pointer here, highlighted, you can see here the gradient at the start again is lower than the gradient at the end. So what does this mean? It means that my gradient is increasing. So increasing gradient using this relationship will also mean increasing acceleration. Okay, so last one will be, you can see again this gradient at the start is lower than this. What does this mean? It means I have a decreasing gradient. Again, using this relationship will mean decreasing acceleration. Okay, I hope you enjoyed this video. Okay, I'll see you guys in the next.